Next up is my partner in crime. Up there, what's left of the 3 extension publications, Ma Prang, Cha-Cha, and the use of dwarf tropical trees in management strategy. I wanted to just say, you know, he was going to give a short course on dwarf trees, but see, you guys don't get it either. I don't understand. Dwarf, short course. Sorry, Sharon, don't take it personally, or Andrea. But anyway, these publications are up there, and I guess tomorrow we'll talk about that one. Talk. No, I won't talk in the mic. Bob can talk.
Thank you very much, Ken. Do you know what you're doing? I mean,
no, I don't.
I'm not sure how to follow on from Mark, wherever he is. He's probably leaving before I start. South Africans are a bit of a problem for Australians. You know. There weren't enough convicts sent out. So.
So where are you from? Where are you from?
Australia. We got a lot of convicts. My ancestors were sent for a minor banking violation. Are we ready?
We're ready.
All right, mate. Can you click the little thing at the bottom there somewhere?
Sorry. Bottom there.
That little screen thing about right there.
That one's good, yeah. Anyway, what I want to talk about today is what Ken asked me to talk about, which is dwarf trees. Now, some of you may recall about 15 years ago, Mike Nagao and I got up here and talked about trimming trees and pruning to reduce labor costs and spread out your needs. But we're coming back to the same issue. So can we have the next slide, please? This is the scene from Gladiator, if you remember the final scene of him walking through a wheat crop. He was claimed to be in Spain, but it's actually in Tuscany, but we'll ignore that part. And we'll ignore the fact that they've got a New Zealander in this movie, which is Russell Crowe, but he did move to Australia, and so he spent most of his life in Australia. The point I wanted to make is that you don't want to take me to movies. I look for problems, and this particular picture has a problem. I was going to choose something from Blazing Saddles, but in Australia I would get away with it, but I don't think I'd get away with it here, so we'll talk about it this way. The problem here is that the crop in this case, which looks like wheat, is only up to his waist, and that is a major problem because in Roman times it would have been up to his shoulders. And so what's happened in this particular case is that we have in fact reduced the crop, annual crops particularly, their heights from about 6 feet to about 4 feet. This is actually this, and what's involved in this is a plant growth regulator, which was mentioned this morning, which was gibberellic acid, GA. And for those of you who remember your biology, maybe, and you talked about Mendel's dwarf peas, it is the same thing. GA is involved in that. It took us 100 years to work that out, but that's a minor point. Anyway, that's the point I wanted to start with. Go ahead on the next slide. So this is another example of, most of the work has been done on annual crops. And this will show you the difference between what crops normally look like. They would be up to 5 or 6 feet. And in old Egyptian tombs, you can see the pictures of these very tall crops, which have now, we've got them much more reduced. And so it improves, the reason why it was done in annual crops, particularly wheat and things like that, was reducing lodging. If you've got a 6 foot high crop, it's very subject to, particularly at the end of the season where you'll get lodging, and this becomes a real problem to pick up with some combines, particularly the older ones. It tends to promote more intensive growth, and it increases the harvest index. And the harvest index is how much grain do you get from the total mass of the crop that you've got, and that's what plant breeders spend time on. Next slide. So, dwarf perennial fruit trees have been studied for centuries. Pruning and training, we've done that for years. Romans, Egyptians, everyone was into pruning trees. Dwarf varieties have been selected, and dwarfing rootstocks and interstocks have also been used for many, many years. I mean, we didn't know why they were, but they have been used widely. And these are some pictures that Ken actually provided from a Japanese book and some other books at the bottom of the thing. Can I have the next slide? Anyway, controlling tree size is important. It's something we talked about this morning, and you lead to more intensive planting. So you're not going to get the same number of fruit per tree, but you're going to have a shorter tree which you can operate and harvest, spray, and do everything, control pruning it as well. And it allows for much more mechanical production. It streamlines operation procedures, particularly if you've got labour being used for pruning and then labour which you retain for harvesting later on. And labour costs are much better. You don't want people on ladders. Ladders are a problem. Cases where people fall off ladders, generally the whole team will stop, particularly if the injury is severe. You also increase fruit productivity, and frequently you'll get earlier flowering in these dwarf trees as well. It optimizes photosynthesis, particularly allowing more light to get into the crop, as we heard this morning. Also ventilation, and it improves fruit quality in many cases because you can go in and do other steps, such as, let's say in mango, you'll only have one fruit per 7 or 8 leaves, and that's what you're going to get, and you get more uniform fruit sizes in the end. So next slide, please. There are unique challenges. Dwarfing mechanisms are less understood in fruit trees than they are in annual crops. We really don't know in many cases exactly what is causing dwarfing in the crops. There is higher mutation rates in fruit trees, but bear in mind that we are in fact generally propagating through cuttings and also grafting. This is generally not a problem. The number of mechanisms proposed for dwarfing in fruit trees is quite amazing, because in pears, dwarfing is just a single gene. But in apples, it's multigenic, and there are interactions between the scion and the rootstock, which in some cases we really don't know what's going on. Next slide, please. Anyway, this is my crude statement of what happened. We do know that plant growth regulators are involved, and the ones that most commonly are auxin and gibberellic acid. Benzoadenine BA is also thought to be involved, but it has to do with that graft union, particularly in the case of propagation by grafting. Generally, it's thought to be associated with increased water uptake or transfer of nutrients in the plant itself. And reduced photosynthesis is thought to play a significant role, but in many cases it's unique to a particular crop. Do we have the next slide? Anyway, these are possible causes. I'm not going to go through it all, but self-incompatibility between the rootstock and the scion is thought to play a major role. Water stress, particularly if the root development is not as extensive in the rootstock, and that will limit the growth of the scion above. Nutritional deficiencies are also thought to play a role in some situations. Hormonal signals, so signals coming from the root to the plant, to the scion or to the top of the tree, and going back down to the roots, which will affect the amount of root growth that takes place. Carbohydrate reserves, so we've talked about in some cases where you get pruning taking place, where you can in fact get a change in the balance of photosynthate going to the root versus to the fruit of the tree as well. Do we have the next slide, Mike? Anyway, so this is what we have for dwarfing. We have natural dwarfs, not too many, but we have some. Use of dwarfing rootstocks or interstocks. So an interstock is where you'd have another section of stem between the rootstock and the sire. Use of bioregulators. I've put that up. It was mentioned this morning. Paclitaxel, I believe, is not approved on fruit trees in the United States, but it is widely used elsewhere in the world. It's an anti-gibberellic acid compound, and it is approved, I think, only on ornamental crops in the United States. It's not approved on any fruit crop, but if you go to Japan or you go to Taiwan or anywhere in Southeast Asia, they spray this and a whole bunch of other chemicals which we can't even think about using.
So we just consume the imports and get them into our system anyway.
You'll survive.
So,
It's one of the company, I'm told, will not consider marketing it in the US or getting a label for fruit crops. They just don't want the trouble because of the costs associated with potential liability. So the other one would be incompatibility of rootstock. So you'll see this in certain situations where, in fact, at the bottom there you can see a poorly developed union between a scion and rootstock where you've got a sort of a dead area in the center. There are other situations where you get this variation as well. Ringing and girdling is also used as a mechanism to give dwarfing, and this is just changing the relationship between photosynthate going to the roots, or CO2 fix, the sugars going down, but also the control of the roots on subsequent growth of the above. So we'll get up to the next slide. Anyway, I'm not going to go through that. There are alternatives there, and you're going to post this, aren't you, somewhere?
yeah.
Yeah, rather. Anyway, so there are in fact frequent, less used ones. There are some viral infections which can lead to dwarfing as well. There are phenolic compounds which can also inhibit cell division, and these are not always used, not widely used. They're very specific in their usage, and so they don't have as wide a distribution as rootstock incompatibility. Now, genetic engineering I've put there, and fortunately I'm not going to talk about that, so I don't know of any situations where people have done genetic engineering for dwarfing, mainly because we don't know what is causing it and what genes to actually work with. Maybe in pear, where you have a single gene, you could do it, but in something like apple or some tropical fruit, you're not going to know what gene to actually modify, so it's pretty much a waste of time. Also, genetic engineering has a problem that's going to take you maybe 7 to 15 years to get anything worthwhile. Anyway, next one.
Why not root pruning?
Root pruning, actually that's interesting you brought that up, because in Vietnam, I always thought rambutan was impossible to get to flower when you wanted it. In Vietnam, there's what used to be a commune. They are actually cycling their trees with root pruning, but what they're also doing is digging big ditches around every tree and then putting plastic over what the surface of the soil underneath the canopy. And any rain they get, this is in the delta, any rain they get will go below the root level, and then they'll remove this after the plant has stopped growing, which is the sort of thing you expect for lychee, you know. So what you want to get lychee flowering, you really need the whole plant to stop all its vegetative growth and have a dormant period. It's not really dormancy in the sense of winter, but it's dormancy in the sense that the plant has stopped growing. And so what they're doing with the rambutan is giving it drought stress to stop growth, And once the vegetative growth has stopped, they will then pull back and irrigate it. And so they were doing blocks of around about 1 acre, 2 acres in sequence around this farm. And they were essentially producing rambutan year round. Now that's off the subject, but you have a potential for doing that sort of thing. Next slide. This is my picture of a wounded plant which is re-establishing its vascular tissue. And that's what the yellow is showing. The plant is actually now trying to repair that damage and grow and develop a new vascular tissue, transmissional tissue around the wounded area. And now you've got to understand plant cells are not the same as animal cells. Plant cells operate slightly differently, but this doesn't take very long. And it will essentially re-establish connections between them. That's what happens in your scion rootstock connections. And that is the biggest problem in the development of scion and rootstocks, because we know with some plants you just can't, it's not possible to actually graft because there's generally latex or other compounds there which make grafting extremely difficult. But plants will do this, start this process within about 24, 48 hours after the injury. They will block off what's damaged and then they'll start to try and develop tissue around it, so they'll re-establish their water conducting tissue. Next slide. Anyway, we do have some dwarf tropical fruit trees. So avocado, we have some bananas. Depending on what you've got, you can go from 30 feet down to 5 to 10 feet. Cashew, there are some. In Brazil, I saw the dwarf ones. They are still a little tall, but you can prune them below. Normally they're 20, 40 feet tall, but you can get them down to 6 to 12 feet. There are, of course, dwarf coconuts, guava, you can see them, jackfruit, there are some, lychee, mango, papaya. Now, I'm not too sure on papaya. I don't believe in this case that in fact papaya is, you can get dwarfs. We were interested in shortening the height at which you got first flowers in papaya, and you can select for that relatively easily. So normally you get about 40, 50 nodes or leaves before you'll get flowering, but you can actually force that down to around about 15 to 20. Now the difference between those will mean that you're starting to get fruit much sooner and getting your return on that investment because you got much lower fruit. Now we gave it up because the pigs decided that the fruit was too low, and they actually ate most of our good ones that we'd eaten. So, but it is possible to do it. Now I don't think in that case it's a dwarf situation. What you're looking at is earliness of flowering, which is a different situation than dwarfing. Sapodilla there is also. Next slide, man.
Do you give any credence to the bigger
Yeah.
credence to the technique of morphing papaya where you put like a stick through perpendicular slits through the trunk?
You can do that, yeah. I mean, with papaya, if you can propagate it from cuttings and things like that, once it's started flowering, it'll continue to flower. And that's why I'm getting back to this point that with papaya, you're not looking at dwarfing in a sense, you're looking at earliness of flowering. Once these trees start their process of flowering, that's it. They're committed to doing that process. I think papaya is a bit strange because it's a volunteer crop in broken canopies. And so that you will see this in Central America where you get the canopy broken. Papaya will be one of the first ones you see growing. And it will grow so fast, set fruit. And the interesting thing with papaya is that if you get root rot, it will gladly kill the bottom of the tree just and put whatever energy it has left from the leaves, it'll put it into the fruit and into seeds. It just doesn't care. Now you can do something I'm not proposing this. Please don't come up to me later and say this is a stupid idea. My wife will agree with you, but don't worry about that. With papaya, you can actually, if you have, let's say, a lot of water saturation, flooding in an area, and the trees start to go down, knock all the fruit off. You're not going to do it, I know, but knock them all off, and that tree will start to recover. And what's happened is that what we've seen is that once it starts to flower and set fruit, the root growth goes almost to zero. So there's actually no growth of the roots taking place once you start to set fruit. And so if you remove the fruit, you're now getting sugars from the leaves moving down to the root and new growth taking place. And so the plant really doesn't care if Phytophthora eats out the whole of the root base. And then you see that browning coming up the stem where it's essentially killing off the plant. But that's off the subject, isn't it? Yeah, man. Not really, no. Once it's started to flower, it just keeps going. It's that initiation of flowering. Most of what we grow here is 40 to 50 nodes or leaves before you get flowering. And we get about 2 to 2.4 leaves per week. So that's why I was saying that if you have a difference of, let's say, 20 leaves, you're looking at a period of 10 weeks of earlier production. So that's not answering your question that struck me. Oh yeah, we've done that actually to induce. Yeah, you can take the top off. You just got to be careful. Sometimes it gets rot in there. But we've done that, and it'll just send out a whole series of branches. Well, it slows down the height for a while, yeah. But generally one of them will take over. You may get 5 shoots coming out the top when you take if you have a high wind and you lose the top, you'll get a burst of new growth, and generally one will take over in papaya anyway. Look for an earlier fruiting one. You want to do that, keep the fruit from that tree. So look for something which is setting fruit sooner. The other would be to also select for avoiding a situation where you've got summer sterility, which is a problem as well. So sometimes in Pune you get situations where you get high temperatures and drought stress, and you'll get no fruit set. That tree will go essentially male during the warm season. And you want to look for trees which don't have that characteristic. You can do it. I mean, it's a very flexible crop to work on. I'm in favor of it. I'm going to retire though, but it's a good crop. Yes, Steve.
For the dwarf mango varieties, are they on their own rootstock?
I'll show you a picture in a minute. Yeah? Next slide. Oh, there's just there's mango and coconut and a few other things there. Next. That's what you can get with papaya. You can get it quite low. But our problem was we don't have enough people to control the pigs on the station, so they just walk through it. Electric fences don't stop them. Next slide.
Harvest the pigs.
We're not allowed to carry firearms on the stations. Anyway, most of the dwarfing rootstocks we see are for temperate crops. And there's been a lot of work done on them, particularly on apples. These are the older lines, the ends are the older ones. There is a lot of work being done out of England in the 30s, 40s, 50s, 60s of rootstocks for apples. And so pears, there's a distinct number, and almonds, there's some, apricots, cherries, and peaches. So most of the temperate crops, there is in fact dwarfing rootstocks. Next slide. Yeah. I don't know if you can.
No, they're grafted on Nemocard rootstock, which is 1800 July.
interesting. One of the big challenges of the 19th century was to work out why there were sweet almonds and bitter almonds. The chemistry was so bad at the time that in fact they couldn't work out why, when they seemed to be contained the same things. And the reason what they were interested in is the perfume industry. And it was the perfume industry which actually led to organic chemistry. So we can blame women and perfume for the creation of one of the courses I dislike the most, which is organic chemistry. It's got nothing to do with this. Next slide. Yeah, man.
Just a question on the dwarfing rootstock. This fundamental question is, what makes it a dwarfing rootstock? Is it the root development is less vigorous? And how does that?
How many pages do you want? Huh? How many? There's multiple potential reasons for it. Poor reconnection, particularly at the graft union. But there's also the fact that sometimes the dwarfing rootstock has poorer root growth, and so that's one of the potential. I think the next slide coming up, no, the one after the next. Anyway, this is just an example of apples. They're all on the different rootstocks, so where it says EMLA is East Moulding, Long Ashton, which is in England, and they did a lot of work. But essentially what they're doing is the same varieties is grafted onto different rootstocks. And this just shows you the range that they can actually accomplish with dwarfing rootstocks. Different dwarfing root, so the rootstocks are different, but the scion is the same. And it's showing you that different rootstocks are having a significantly different effects on different rootstocks. And so the scion in this case is all the same. This is out of Washington State, and the rootstock is what's different. And that'll tell you that there's clearly that interaction between the rootstock and the scion, but that varies with variety. And so that's the next question, next slide. Anyway, this is what we have for, Ken gave me a hand with this. This is what we have for tropicals. There are Nona, Anoviaceae, Rollinia. Now, Rollinia is no longer an approved genus name, but you keep calling it Rollinia. It was the taxonomists of, you were talking about lumpers and splitters. This is a case of lumping. So they got rid of this genus Rollinia and put it back into a Nona, where it actually was in the 17th century, but ignore that. Breadfruit, Camito, citrus, guava, loquat, mango, sapodilla, and sapinus. Let me, next slide. So this is just some examples of scion dwarfs, in this case, that we can see quite commonly for tropicals. Next. This is my slide. Some of me asked about citrus. I find citrus taxonomy to be a complete and utter mystery. Citrus, they now regard, these are lumpers and splitters, the taxonomists now only regard 4 species of citrus. And the 4 are given in the center there, citron, mandarin, pomelo, and papeda. So this are the 4. Everything else is hybridization, back hybridization, recrosses, collections, and this is why I always have trouble with this. Now, Comasi is thought to have been a cross between Fortella, which no longer exists by taxonomists. It's been moved into the citrus genus, and probably one of the limes. So, but that's what it looks like now in the world. But I've always been a little confused with citrus. It's just an area I've stayed away from. Next slide. But there are in fact dwarfing rootstocks. And this has been the major. Now, with the exception of Washington Navel, which is a terrible name, but anyway, the Californians decided to call it Washington Navel. It was collected out of Brazil and brought into Washington, D.C. into the Introduction Center by one of the people working for USDA. And he gave it to a friend who was studying growing citrus in California around Riverside. And they decided, the growers decided in California that they were going to call it Washington. That's the only reason it's called Washington. Again, it's seedless as well. But these are the rootstocks which are available for different species, different citrus. Next slide. Anyway, there are interstocks as well, and so there's a lot more work done on citrus than there is on most of the other tropical crops that we have. Navel oranges, you can use Voldmere and sour orange as the interstock, which is generally it's only a small section, can be bigger, but it's not. Mexican lime and Satsuma mandarin using this flying dragon one, which is commonly around as well. Next slide.
So why would you use an interstock?
To get it even smaller. Sometimes with citrus, there's a problem in the connection between the two, and generally you go into a rootstock, and generally you can get a difference in the height response that you'll get out of it. This looking at the publications in this is a minefield as far as I'm concerned.
Well, you could look for disease resistance
Yeah.
in rootstock and then
Yeah.
dwarfing
Yeah.
and then interstock,
Yeah,
right?
yeah,
Well, there's different rootstocks are resistant to different problems,
yeah.
like tristasia or greening.
Yeah, I mean, rootstocks, yeah. It's unfortunate that we haven't done much of this type of work in Hawaii. There is some out of Florida and there's some out of Southeast Asia, but we've dropped that area of study for reasons which will remain. Never mind. Next slide. Anyway, but there are disadvantages in dwarfing trees. Frequently they have shallow root systems, but this may be an advantage, particularly if you've got water enough. If you've got a shallow root system, it may mean that the tree is going to be shorter, more vulnerable to water stress, particularly if the tree's rootstock is, the roots are not as extensive. Frequently they may have a shorter lifespan, and we've seen this in a number of crops. Avocado is one, I think, but also citrus is another one. Produces less fruit compared to standard sized trees. Now, that may be an advantage, as we talked about this morning, if dwarf trees give you the advantage of operating from the ground and at least being able to harvest everything that's set, whereas tall trees are just a major problem. Some dwarfing rootstocks can be susceptible to specific diseases, and Ken just mentioned that. So the choice of rootstock really depends on what your disease pressure is in the soil versus what your aerial disease is. Next slide. Yeah, no.
In citrus, don't you think that the dwarfing trees produce more per square foot of ground area, but not more per tree?
Probably do.
I think so.
Yeah. Yeah, I you know, in Taiwan and I presume also in Japan and elsewhere, with mango, they're only looking at 2 meters, 2.5 meters. Now, the people are shorter, but I can't say very much about this. My wife is somewhat down there. She's shorter.
So is that kind.
She must be, she who must be obeyed. They will, in fact, only keep them a couple of meters, and they will actually go through and spin the fruit and bag the fruit. And in fact, what they end up with is uniformity in fruit size with no essential blemishes on the outside. And that's one of the reasons they do it, because they now can market a uniformity of size, and the cull rate in their packing sheds goes from 30 to 40% to essentially about 10%. And so everything you're harvesting, you're essentially packing instead of having to get rid of seconds and things like that. Thank you very much.